Okay, so what I'd like to do is talk about Play-Doh, just plain old regular Play-Doh. It turns out the Play-Doh that you get at your house from the store, or the Play-Doh that you make at your house, can be conductive, electrically conductive. So just to prove my point, I've got two lumps of Play-Doh here and a battery pack, and I'm going to simply plug those in, and I've got a LED. This is a blue LED, and when I plug it in, you can see the light comes on. And I've got other colors as well that we'll be playing with. So I've got red, and the red light comes on. Now, what I'd like to do is talk about circuitry and how easy it is to build circuits if you have small hands. If you're a first grader, second grader, very easy to work with Play-Doh. Let's talk about working in parallel. So here I have a red light that is on, and I can put a second one, and if the camera can pick it up, they are both on. However, if I take this red one out and put this blue one in place, the blue one does not come on unless I take the red one out. So now we've got the blue light on. Whoops, let me twist this around. Blue light is now on, but if I add the red light, the blue light goes off and the red light comes on. The reason is the electricity would rather go through the red light, and it does not want to go through the blue light unless that's the only path it has. Let's talk about a short circuit. So here I have my Play-Doh. There's no circuit now, and now there is a circuit, and we've got a blue light on. But if I touch the Play-Doh together, you'll see that the light goes off. And the reason for that is the electricity would rather go through the shortest path, so it finds a short path rather than going through the light, so a short circuit. Now, I've got a second kind of Play-Doh over here. This one is a different formula, made with salt instead of, made with sugar instead of salt. And it turns out that this one is electrically resistive. So I can put that in the middle, squish everything together. I'm not sure if the camera's picking it up. Okay, so using those techniques, I can build some interesting circuits. Different Play-Doh and different Play-Doh. And we'll plug the electrodes in here for my battery pack. I'm going to take a red and another red, and now both reds are on. So now I've done what's called in series instead of in parallel. And same thing, I could insert little bits of the resistive dough between and squish everything together, and my lights will stay on, because the electrical path, it would prefer to go through the light than through the resistive red dough. And there we have electrical circuits, series and parallel, with electric diodes and a battery pack using Play-Doh.
To find out more information about this, go to Google and search for squishy circuits. And you'll find the link to Squishy Circuits, which is from St. Thomas University. And you'll find the recipe for making conductive dough, you'll find the recipe for making insulating dough, and you'll also find the circuits that I built. Now, they also made some with sound. There are some videos in place that you can do, so you can find that at Squishy Circuits. If you'd like to know where I found out about Squishy Circuits, I found it from the TED website. These are riveting talks by amazing people. And you can find the Squishy Circuits TED Talk by going to TED.com and searching for Squishy. You'll find it here. A very nice, professionally produced video on Squishy Circuits from St. Thomas University.